Today we will solve one problem, and the problem is and the question is: given a random sample of size 1 under h0, x follows uniform 0, 1 distribution. Under h1, x follows a triangular distribution with the density f of x equal to 4x if 0 less than x less than 1 by 2, 4 into 1 minus x if 1 by 2 less than equal to x less than equal to 1. Construct most powerful test for testing h0 versus h1. Right here, the test is here the sample size 1, right? Then the sample random variable under h0, sample random variable follows a uniform 0, 1 distribution, and under h1 that sample random variable follows triangular distribution with this density. Okay, here what is a triangular distribution with the density? What is a triangular distribution? Triangular distribution is a continuous probability distribution with the lower limit is a and upper limit b mod c. Okay, triangular distribution with a probability density function with shape like triangle. It's like triangle where a is lower limit, b is upper limit, and c is the mode of that. Okay, where a is less than b, right? And a is less than equal to c, less than equal to b. This is like the triangular distribution. Here in this problem we have to construct most powerful test, right? So for that we have to take the ratio of density, right? Here because of here sample size 1, right? For that we have to take the density, ratio of density. Here what is a under h0, under h0 what is the density? Is given that x follows under h0, x follows uniform 0, 1, right? Then we have to write here f0 of x equal to the density of uniform 0, 1. That is f0 of x equal to 1 if 0 less than x less than 1, right? 0 otherwise. Then what is under h1? Density under h1 f1 of x equal to, it says that a triangular distribution with the density f of x, right? This density, right? That is f1 of x equal to 4x if 0 less than x less than 1 by 2, 4 into 1 minus x if 1 by 2 less than equal to x less than equal to 1, right? Here we need to take the ratio, right? f1 of x divided by f0 of x. But here the x limits are changed, right? Here 0 to 1, here 0 to 1 by 2, and 1 by 2 to 1, right? For that we have to make some changes here, right? We can split the range. Then we can write f0 of x as f0 of x equal to, here range, right? 0 less than x less than 1 by 2 if 1 by 2 less than equal to x less than equal to 1. That is under h0, f0 of x is 1 if 0 less than x less than 1, right? That is here 1 if 0 less than x less than 1 by 2, and here also 1, right? 0 to 1, f0 of x is 1, right? Then we have to take the ratio, right? That is here rejection region is f1 of x divided by f0 of x, right? Which is equal to here 0 less than x less than 1 by 2 if 1 by 2 less than equal to x less than equal to 1 otherwise, right? Here what is the value? If 0 less than x less than 1, 0 takes the value 0, x takes the value 0 to 1 by 2. Then what is a ratio? 4x divided by 1, right? That is a 4x itself, right? Then if x takes the value 1 by 2 to 1, and then what is the ratio? 4 into 1 minus x divided by 1, right? That is 4 into 1 minus x, 0 otherwise, right? Then here we need to obtain the what is the rejection region, right? For that, here x takes the value 0 to 1, right? We will here we will substitute the values of different values like 0 to 1. Then we will obtain what is the ratio. Then we will calculate the values. Okay, so here we will take some values like here x range is 0 to 1, right? 0 to 1. So we will take some values like 0, 0 0.2, 0 0.4, 0 0.5, 0 0.6, 0 0.8. Okay, then what is the ratio f naught of f1 of x divided by f naught of x? So here x is 0, right? Then the ratio is we will take the ratio these, right? 4x, right? 4x into 4x, right? If x takes the value 0 to 1 by 2, then ratio is 4x, right? If x takes the value 1 by 2 to 1, then the ratio is 4 1 minus x, right? Here then what is the value? If x is 0, then that value is 0, right? Here 1 by 0 0.2, then you have to take 4 into 0 0.2, right? That is 0 0.8. Here also 4 into 0 0.4, that is 1.6. Then here 0 0.5, right? That is 1 by 2, right? If x takes the value 1 by 2 to 1, then the ratio is 4 into 1 minus x, right? Then this value is, what is the value then? 4 into 1 minus x, that is a 4 into 1 minus 0 0.5, then 4 into 0 0.5, which is equal to 2, right? Then if x takes the value 0 0.6, then here also we have substitute 0 0.6, right? That is 1.6 here. For x equal to 0 0.8, then the value is 0 0.8. Then 1, then value is here 4 into 1 minus 1, 0, right? 0, right? Then we will draw the graph by using that values. Okay, that is we'll draw the graph. Okay, this is the graph, and we will take the values, right? 0 here is x values, and here the ratio, right? That is f1 of x divided by f naught of x. X takes the value 0 0.2, 0 0.4, 0 0.5, 0 0.6, 0 0.8, and 1, right? Then here these values like 0, 0 0.8, like this type, right? So we'll take 0, 0 0.5, 1, 1.5, 2, 2.5. Okay, so here if x takes the value 0 0.2, then is 0 0.8, right? And for 0 0.4 is 1.6. For 0 0.5 this is 2, 2, right? 2, right? And then for 0 0.6 is 1.6. For 0 0.8 it's right? Then for 1 is 0, right? It's like, so it's like this type. Okay, so it's like a triangle, right? So from these we have to obtain the rejection region, right? Here we will take this maximum, these are maximum, right, value. We take some value k 1, and here also we will take some value k 2. Okay, so then the rejection region is there are two rejection regions, right? That is k1 k1, this is one rejection region and this is one rejection region, right? K1 less than x less than 1 by 2, or 1 by 2 less than x less than k2. Okay, this is two rejection region. Then we will write the test function. Okay, the test function is phi of x equal to 1 if k1 less than x less than 1 by 2, or 1 by 2 less than x less than k2, right? 0 otherwise. So then using this we have to obtain k1 k2 values and power of the test. Okay, using size condition, size of the test, that is alpha equal to expectation of phi of x under h naught, phi of x under h naught, right, which is equal to probability of k1 less than x less than 1 by 2 or 1 by 2 less than x less than k2, right, under h naught is equal to probability of k1 less than x less than 1 by 2 plus probability of 1 by 2 less than x less than 1 less than k2, right? Which equal to, if we will take these as like here integral over k2 1 by 2 and 1 by 2 to k2, right? If we will take this as together, that is k1 2, that is probability of k1 less than x less than k2 equal to alpha. This is similar, right? But using this we cannot find out the value of k1 k2 separately, right? If we will take these type, this is wrong. Okay, this is wrong. But if you'll try what is the wrong, you'll test what is the wrong. Okay, if you will take a probability of k1 is less than x less than k2 equal to alpha, that is, if you will write here, this is right, k1 to 1 by 2 x, sorry, f of x dx plus 1 by 2 to k2 f of x dx. Similar, right? That we can write this is together, that is the integral over k1 to k2 f of x dx, right? Here we will try that integral over k1 to k2 f of x dx equal to alpha under h naught, which implies k1 to integral over k1 to k2. What is the f naught of x is 1, right? 1 dx equal to alpha, which implies x k1 to k2 equal to alpha, which implies k2 minus k1 equal to alpha. Here we cannot get the values of k1 k2 separately, right? If k1 equal to, if we want to determine k1 value, that is k1 equal to, what is k1? k2 minus alpha, right? Now what is k2? Alpha minus k1. So here we need a if we want to find out k1 value, then we need k2 value, right? If you want to obtain k2 value, then we need k1, right? So this is not a proper method, right? This is not a proper method. So here it is a or, right? You can take is a, we can write these as probability of k1 less than x less than 1 by 2, or which implies probability of k1 less than k x less than 1 by 2 equal to alpha by 2, or probability of 1 by 2 less than x less than k2 equal to alpha by 2. Okay, so here we will take here alpha equal to probability of k1 less than x less than 1 by 2 plus probability of 1 by 2 less than x less than k2 equal to alpha, right? Then we will take separately is there is a probability of k1 less than x less than 1 by 2 equal to alpha by 2, or probability of 1 by 2 less than x less than k2 equal to alpha by 2. Okay, then we will solve that, which implies first we will take this term only. Okay, it is integral over k1 to 1 by 2 f naught of x dx equal to alpha by 2, and here or integral over 1 by 2 k2 f naught of x equal to alpha by 2, right? Which implies here what is the f naught of x is 1, right? That is k1 to 1 by 2 1 dx equal to alpha by 2, or integral over 1 by 2 to k2 1 into dx equal to alpha by 2, which implies then integrate this term, then we can get x k1 to 1 by 2 equal to alpha by 2, or here also x 1 by 2 to k2 equal to alpha by 2, right? Which implies 1 by 2 minus k1 equal to alpha by 2, or here k2 minus 1 by 2 equal to alpha by 2. Then we will get k1 equal to, what is that k1? 1 by 2 minus alpha by 2 here, or k2 equal to alpha by 2 minus 1 by 2, right? Which implies here k1 equal to 1 minus alpha by 2, right? Or here k2 equal to alpha minus 1 by 2. So this is the k1 k2 value. Okay, next we have to find out what is the power of the test, right? It is power of the test beta equal to probability of under h1 k1 less than x less than 1 by 2, or 1 by 2 less than x less than 1 by less than k2, right? Less than k2, right? Is equal to probability of k1 less than x less than 1 by 2 plus probability of 1 by 2 less than x less than k2. Okay, under h1. Then it's equal to, you can write k1 to 1 by 2. And what is the density? f1 of x, right? Dx plus integral over 1 by 2 to k2 f1 of x dx, right? Power under h1, right? Which equal to k1 to 1 by 2. What is f1 of x when x takes the value k1 to 1 by 2 is 4x, right? Under h1 the density is 4x, right? Place here integral over 1 by 2 to k2, the density under h1 is 4 1 minus x dx, right? Then we will integrate this term, that is 4x squared divided by 2 k1 to 1 by 2 plus 4, integrate that term, right? It is 4 into then you can get 4 into x minus x square by 2, right? Limit is 1 by 2 to k2, right? It's equal to here 4 and 2, right? Then remaining 2, that is 2, here 1 by 2 square minus k1 square. Here substitute the values, then here also you will substitute the value, right? That is 4 into, first we will substitute this value, that is k2 minus 1 by 2, then minus this term. Okay, that is k2 square divided by 2 minus 1 by 2 square divided by 2. Okay, which equal to is equal to 2 into 1 by 2 power 2 minus k1 power 2 plus 4 k2 minus 1 by 2. Here also we will take k inside, sorry, 4 inside. Okay, then 4 k2 square minus 1 by 2 square divided by 2, right? Here 2 to cancel, 2 here 4, right? 4 2, then can get here 2, right? It's equal to, then you will simplify this term, right? Okay, then substitute the values of k1 and k2. Okay, then simplify the terms. After 4-5 steps, like 5-6 steps, you will get the final answer. So that's your homework. Okay, find out the power of the test. Next we will solve one another problem like this type of, and the question is given a random sample of size 1 under h naught, size 1 under h naught, x follows uniform 0 comma 1, and under h1 that is a density. Okay, that is a f of x equal to 2x, where x is lies between 0 and 1. Then construct most powerful test for testing h naught versus h1. Okay, so here the question is given a random sample of size 1 under h1, under h naught, x follows uniform 0 comma 1, and under h1 is a density, that is a f of x equal to 2x, 0 less than x less than 1. Construct most powerful test for testing h1. Like, so here we have to take the ratio of density under h1 and density under h0, right? Because it's sample size 1. Okay, under h0, f0 of x equal to, here uniform 0 comma 1, right? That is, then the density is 1 if 0 less than x less than 1, 0 otherwise, right? Then under h1, f1 of x equal to, what's under h1? Density is 2x, right? 2x if 0 less than x less than 1, 0 otherwise. So then we have to take the ratio, right? That is a rejection region, that is a f1 of x divided by f0 of x, right? Here it's simple, right? That is a 2x by 1, that is 2x if 0 less than x less than 1, 0 otherwise. And here also we will substitute the values between 0 and 1 for x, then calculate the ratio. That is, here we will take x values 0 to 1. We will take that 0 0.4, sorry, 0 0.2, 0 0.4, 0 0.5, 0 0.6, 0 0.8 and 1. Okay, then what is the ratio? f1 of x divided by f0 of x, that is 2x, right? That is 0, 0 0.4, 0 0.8, 1.0, then 1.2, 1.6, then 2, right? Then we will draw the graph. Here x values and here the ratio, right? Here the function 2x, right? Then we can say that is a increasing function, right? Then we will take it as a large ratio as a, here is take 1 0 is a lies between like 0 0.2, 0 0.4, 0 0.5, 0 0.6, 0 0.8. Okay, here we'll take one values like k to 1. Okay, this is a large range, highest value, right? Highest ratio value we'll take is k, and the last value is 1. Okay, because x takes the value 0 to 1, right? Then we get the upper limit is 1. Okay, then here the rejection region is k less than x less than 1, right? This is the maximum large value. That is rejection region is k less than x less than 1, right? Then we have to find the value of k, right? Using size of the test. For that, first you have to write the test function, right? Then the test function is phi of x equal to 1 if x is greater than k, 0 otherwise, right? And then using that we have to obtain the value of k, right? For that, first we have to find the size of the test. Size of the test alpha equal to expectation of phi of x under h naught, right? Which implies probability of x is greater than k under h naught equal to alpha, right? Which implies integral over k to under h naught is take the value, x takes the value 0 to 1, right? Here k to 1, and f naught of x dx equal to alpha, which implies integral over k to 1. What is f naught of x? Under h naught, x follows uniform 0, 1, right? Then f naught of x is a 1. The density of uniform 0, 1, that is 1, right? 1 dx equal to alpha. Then integrate that term, that is x k to 1 equal to alpha, which implies 1 minus k equal to alpha, which implies what is value of k then? K equal to 1 minus alpha. So this is the k value, right? Then we have to obtain the power of the test, right? That is beta equal to expectation of phi of x under h1, right? Which implies probability of x is greater than k under h1 equal to beta, which implies integral over k to 1, right? What is the density? f1 of x, right? dx equal to beta, which implies integral over k to 1. f1 of x is 2x, right? 2x equal to 2x dx equal to beta, right? Which implies integral over k to 1 2x dx equal to beta, right? Which implies we have to integrate that term, that is 2x square divided by 2 lower limit, upper limit, right? Beta. Here 2 would cancel, then 1 minus k square equal to 1 minus k square equal to beta, right? Which implies 1 minus, what is the value of k? K is 1 by 2, right? It is 1 by 2 square equal to beta, which implies 1 minus, here 1 plus 1 minus alpha square is 1 plus alpha square minus 2 alpha equal to beta, right? Which implies 1 got cancelled, then minus alpha square plus 2x, right? 2 alpha, right? It is 2 alpha minus alpha square equal to beta. This is the power of the test.